All right, let's give this a try. So we're going to have a net force that's going to be acting on some object. And I've gone ahead and I've made my picture. Forgive me for it being sloppy, but we have a force of 4 newtons acting to the east, a force of 10 newtons acting 60 degrees south of the west line, and a force of 7 newtons acting north. So what we're going to do, the important thing here to remember is we need to look at what's happening in terms of our vectors. So it means we need to keep our x and our y coordinates separate. So we're going to look at the sum of the forces that are happening in the x direction and the sum of the forces acting in the y direction. Now, of course, you get to pick what is x and what is y. I personally am going to say, let's call this x, and that'll be the positive x. And let's call this y. All right, I don't want to hear about it in class when this looks so sloppy. All right, so we are going to set up what's happening for each the x and the y. I can see here that my force 1 is in the positive x direction, and my force 2 in the x, force 2 has an x component, that's going to be in the negative because it's in the opposite direction of what I chose to be positive. Same thing's happening down here, your force in your y direction. I see that my force 3 is going to be in the positive direction, and my force 2 in the y direction is going to be in the negative. So I know the numbers for this and for this. I need to use some trig functions to find these values. So what I personally do, I like to see my triangles separate. And this is going to go back to what you learned in your Math 2 classes. Just some simple trig functions. So if you want to solve for, let's say, f2y. You know the hypotenuse. You want to solve for f2y. That means you're going to need to use the sine ratio for the reference angle that we know. Our sine of 60 degrees is going to be the opposite side. Oops, sorry. Hold on. All right, so it's going to be your opposite side over your hypotenuse. Simple as that. And so just do a little bit of rearranging and you know what this value is going to be. Same thing when we want to solve for our x component. You want to find the x component. You know the hypotenuse. That means you're going to need to use a cosine. Since we have adjacent and hypotenuse, it's going to be the adjacent side over the hypotenuse. Do some rearranging, and you will find exactly what the x component will be equal to. So now when we come over back to our equations, we can go ahead and plug in our values. f1 was equal to 4. f2 in the x direction was equal to 10 cosine of 60 degrees. And these will just equal a number that you put in your calculator. If I remember correctly, this will equal -1. And when we're talking about the sum of the forces in the y direction, we're going to take 7 minus, come over here and get our f2y, 10 times the sine of 60 degrees. And sorry if I get this wrong, if I remember correctly, it was equal to -1.66, or approximately equal, because of course that's an irrational number. Now, when we're looking for the net force, we really often are concerned with both the direction and the magnitude. If you want, you can absolutely leave your vectors in vector notation. And with vector notation, just a reminder, what you're going to do and of course net means total. You will draw it like you would a point with your x first and your y second. The only difference between a vector and a coordinate is you put brackets around it instead of parentheses. Now, if we want to know the magnitude of the force, how big is the force, how much do the forces add together and cancel each other out, it's really, you learned from Mr. Pythagoras back years ago. We're going to take this, we're going to make a new triangle. Let's see, we're going to go -1 in the y direct, or in the x direction, -1.66 in the y, and let's see, I'm not necessarily drawing this the correct way. I'm just going to make any triangle though, because my goal is to find the length of the hypotenuse. I'm not going to care about direction when I'm talking about magnitude. So this is, of course, going to be a right triangle, because x and y are always perpendicular to each other. Use the Pythagorean theorem. And that will give you the magnitude. And I don't have a calculator on me, so I'm going to leave that to you, but I trust that you can handle that much.